Okay, I'm going to go ahead and solve this rational inequality. And we'll start out, the first thing I would do is I'm going to factor this. I don't like the way the numerator looks. Okay, I'll leave the denominator alone. And it's x and x. My signs have to be different. And I'm looking for numbers that multiply to 8 and then subtract to 2. And it looks like 4 is going to work here and 2 is going to work there. And I'll do a quick check. My outers give me negative 4x. My inners give me positive 2x. And that would factor. Okay, a couple things we need in order to graph. Number one, I need x-intercepts. And x-intercepts are wherever we produce a 0 in the numerator. So in that first set of parentheses there, it looks like negative 2 would produce a 0. I'm going to write as a coordinate point. And in the second set of parentheses, it looks like positive 4 would produce a 0. Okay, I'm going to go ahead and put dots at negative 2 and positive 4. And you'll notice they're closed circles because my inequality is less than or equal to. Okay, number 2, I'm going to put a y-intercept in. And this is anytime I'm plugging 0 in for x values. So I look at my original. If this is 0, 0, and 0, I'd be left with negative 8 over 4, which we know is negative 2. So we'll go ahead and plot that point and make sure you double check your scale here. The next thing I'm going to find is my vertical asymptote. That's pretty easy. And that's whenever I produce a 0 in the denominator. And the only thing that will produce a 0 there is negative 4. X equals negative 4. And again, there's always confusion. I thought we can't have a 0 in the denominator. Why can x equal negative 4? That is not saying I'm plugging in negative 4. It's saying I have a magic line here, and that's the equation for that line, that my math can never cross because we're not allowed to divide by 0. Okay, next, normally I would find my HA, horizontal asymptote. But since I'm in a scenario here where I look at my original rational polynomial function here, and I notice I'm in a top bigger scenario. So this means there is no, but it does mean that there's slant. So slant asymptote. And we'll do that over here. So x squared minus 2x minus 8. We're going to do some polynomial long division. And I'm going to divide that by x plus 4. And my goal is to get this leading variable here to equal this leading variable. And we know we have to multiply by x. And it's a lot like distributing. I'm going to multiply x by x. I'm going to multiply x by 4. And down here I would get x squared. I would get 4x. I put a line underneath it. And then I change both signs because I'm subtracting that entire bottom row. And now I get negative 6x minus 8. And again, what do I need to multiply that leading outside variable by to turn into this? And my answer is negative 6. And it's a lot like distributing again. I get negative 6x. I get negative 24. I put a line underneath it. I change both signs. This goes away. And then I could do negative 8 plus 24, but I don't really need it. It's 16. And this is the remainder, which does nothing for me. But what I want here is, move this over, my slant asymptote, which is going to be y equals x minus 6. And I'll go ahead and plot that on my graph. Now, you'll notice I don't have great intervals on this, and that's okay. If I did have a slope of rise 1, run 1, if it crossed at negative 6, it should cross at positive 6. So we'll go ahead and make a line that runs through these 2 points. We'll extend it this direction. And there's our slant asymptote. Okay, we're going to do a quick sketch of this in the calculator and see what it looks like. So I have my calculator on. You'll notice I preloaded my original equation with parentheses. I also changed the window. I went down negative 30, so it looks like my window here. and I hit graph, and you should get something like this. Now, another way to double check your slant asymptote is go ahead and type it into y2 here, x minus 6, and when I hit graph, perfect. Okay, it does not cross. And I'll pull this down here for notes purposes. Okay, so you should have something that goes like this. Just got to go through these 2 points. And then you should have something that's pretty much equal to that down here. Okay, now we're not done. There is a solution here. And I'm going to highlight the stuff that is all greater than 0 for my y values, and that's all the stuff above the x-axis. And then I'm going to highlight in blue all the stuff that's less than 0, and that's all the stuff that is below the x-axis. And when I look at my original inequality, I decide, do I care about the blue stuff or the yellow stuff? Well, it says less than or equal to, so I care about all the blue stuff. So let's start off with this part of the graph. I need to deal with all this stuff. And my x values go to the left forever, so that's negative infinity. And then as I'm approaching this blue line, I'm going to get closer and closer and closer to it, but never actually touch it. And that blue line is at -4, open, u. And then I'm between these 2 red dots here. And those red dots occur at -2 and +4. And I can touch both of those, so it's a closed bracket. And that's my final answer.